Right, is the screen up there, Dean?
The screen is up and it's working fine.
Good, thank you. Good evening, all. Thank you very much to the Royal Society for inviting me to talk about my search for coelacanths. And thank you, Dean, for hosting and chairing this evening's event. My story, like most stories, begins a long time ago. During my last year at university, I came across a neglected yacht at Point Yacht Club in Durban. The vessel had sunk on her moorings a few times and had been pumped out and recovered. I approached the owner and struck a deal whereby I would restore the boat to full seaworthiness, and in exchange I'd get to use it for a year. I spent every non-class and several class hours on the boat and rebuilt her completely. Nothing flash, but seaworthy. After my last exam, my wife, my brother, and I jumped on board and we set sail. We sailed from Durban to Richards Bay, and from there in early 1992, we set off on a 2-week crossing to our first stop, the Comores, an archipelago of 4 islands situated between northern Mozambique and Madagascar. The islands were very basic, but absolutely beautiful. Massive volcanic structures rising up from the depths of the Indian Ocean. Surrounded by deep, incredibly clean water, it was a diving paradise. And most importantly, it was the home of the coelacanth. We had a wonderful time in and around the islands, and I took away many lasting memories. But there were a few particularly important legacies from our 2 or 3 months in the Comores. Firstly, lifelong friendships. Yves Dudekem was a young Belgian doctor who was and is still crazy about diving. Yves is now a world-leading pediatric cardiovascular surgeon based in Washington, D.C., and we meet regularly for dive expeditions in various parts of the world. Said Yusuf, a Comorian, who we hired to drive our dinghy around, following our bubbles while we dive to crazy depths. Said has visited us in South Africa several times. I sponsored Said's young brother, Ahmed Hamadi, to train as a millwright here in South Africa. Ahmed remains a very close friend and now works in Paarl and skippers my dive boat on weekends. And it was my time in the Comores and the incredible diving on deep, lunar-like volcanic cliffs, canyons, and caves that instilled in me a burning desire to dive with coelacanths. I'd always been interested in the coelacanth, the prehistoric fish, long thought to be extinct, but making an appearance in the 20th century. I didn't know a lot about the fish and its fascinating story, but I knew that the first living specimen had been caught off the South African coast at a depth of about 40 fathoms, or 70 meters, that it had been identified by J.L.B. Smith, and subsequently many had been found off the Comores. Diving to 70 meters is a pretty serious affair. We do so regularly today with mixed gases, multiple cylinders, and carefully planned decompression schedules. Back then, we only had 10-liter single cylinders and compressed air, along with a good dose of youth and stupidity. I had done enough diving to know that oxygen becomes toxic at a partial pressure of over 1.6 bar, which meant that the maximum depth we could dive to on air, which contains 21% oxygen, was about 70 meters. But 70 meters is 40 fathoms, perfect for finding a coelacanth, we thought. We dived often to this depth. We had a compressor on the foredeck of our boat, and when we weren't diving, we were filling cylinders. We only had 4 cylinders on our boat. We carried 1 each and dangled another 2 below our little dinghy, which we could recover on the way up and on which we could complete our decompression stops. This was, needless to say, an extremely dangerous arrangement. Apart from a wholly inadequate supply of breathing gas and bordering on oxygen toxicity, the nitrogen content in air becomes narcotic at about 30 meters. And at 70 meters on air, one is quite literally knocked out of your mind. On one such dive in this incredible deep rocky canyon, a huge fish swam past us. A tuna, I thought. Yves went berserk, and when we were back on the surface, he claimed it was a coelacanth. I had to convince him otherwise, and he grudgingly accepted that it was the nitrogen narcosis that had got to him. Despite many hours spent underwater at depths of up to 75 meters, I didn't find my coelacanth in the Comores. However, when Said first visited us back in South Africa, he brought with him a consolation gift, a wooden carving of a gombessa, the Comorian word for coelacanth. So while my coelacanth story began a long time ago, the real story begins a very long time ago. On the 22nd of December 1938, a living coelacanth, a fish thought to have been extinct for some 70 million years, was trawled off East London coast, sparking a worldwide sensation. There were three important characters involved in this incredible find. Henderson, the captain of the fishing vessel Nerine, Marjorie Courtney Latimer, the young curator of the East London Museum, and of course, Dr. J.L.B. Smith, the soon-to-become world-famous ichthyologist. Captain Henderson recalled that it had been a stormy day with a cold water upwelling reaching onto the continental shelf. He had not landed many fish on his usual run and decided to shoot his net once more about 5 miles offshore from the Cholumna River mouth to catch some edibles and some inedibles for the friendly young curator at the East London Museum. Once the Nerine had docked, Marjorie Courtney Latimer received a phone call on her brand new phone installed 2 days earlier from an I&J manager, informing her of the bycatch to which she could help herself. She recalls that it was a particularly hot day and she was busy finalizing a fossil display at the museum and really did not want to go down to the dock to scratch through a pile of shark and the like. She finally decided to catch a taxi down to the dock as she did not want to offend the generous I&J staff. Also, she recalled it was close to Christmas and thought it would be right to go and wish them well in person. She was immediately struck by the strange but most beautiful blue fish and hauled it off to the local taxidermist so it could be preserved while she sought the help of Dr. J.L.B. Smith to identify it. Dr. J.L.B. Smith was at the time a chemist and ichthyologist at Rhodes University in Grahamstown. Courtney Latimer wrote to Smith, who was holidaying over Christmas at his favorite getaway, Knysna. She set out the details of her finding as follows. Dear Dr. Smith, I had the most queer-looking specimen brought to notice yesterday. The captain of the trawler told me about it, so I immediately set off to see the specimen, which I had removed to our taxidermist as soon as I could. I, however, have drawn a very rough sketch and am in hopes that you may be able to assist me in classing it. It was trawled off Cholumna at about 40 fathoms. It is coated in heavy scales, almost armor-like. The fins resemble limbs and are scaled right up to the fringe of the filament. The spinous dorsal has tiny white spines down each filament. Note the drawing inked in red. I would be so pleased if you could let me know what you think, though I know just how difficult it is from a description of this kind. The letter was accompanied by this delightful and now iconic sketch. At the time, the most recent evidence of coelacanths were 70-million-year-old fossils, so you can imagine Smith's bewilderment and excitement. He identified the fish as a coelacanth and named it Latimeria cholumnae, after Courtney Latimer and the river of which it was caught. The story of Smith's identification of the coelacanth and the ensuing worldwide sensation is well told. So the coelacanth story, in fact, begins a very, very long time ago. The most ancient fossil specimens of coelacanth were found in Devonian rock, making it between 375 and 410 million years old. And as I've just indicated, the most recent specimens dated back 70 million years. And very little has changed in all this time in this grand old fish. Fishes are essentially divided into three classes. Chondrichthyes, or cartilaginous fishes, like sharks and rays. Actinopterygii, or spiny-finned fishes, the fish that we all know. And Sarcopterygii, lobe-finned fishes, most of which are extinct except for lungfish and coelacanths. Sarcopterygii are vertebrate animals with pectoral and pelvic fins or limbs set off from the body on a muscular pedestal containing a series of bones. hence Smith's nickname of Old Forelegs for his coelacanth. They include lobe-finned fishes, as well as all vertebrate animals known as tetrapods, including amphibians, reptiles, birds, and mammals. So in an evolutionary sense, all tetrapods, including us, are essentially limbed fish, because our ultimate vertebrate ancestor is a fish. So the coelacanth timeline is as follows. The first records of coelacanths date back about 400 million years. Prior to the 1938 find, the most recent records date back 70 million years. In 1938, the live coelacanth is found off the South African coast and is identified and named by J.L.B. Smith. In 1952, a second specimen is caught off the Comores. Several specimens follow from the Comores, then Mozambique, Madagascar, Kenya, and Tanzania. In 2000, a group of mixed gas technical divers, led by the late Peter Tim, make the stunning discovery of coelacanths at depths of around 100 meters in the Jessa Canyon off Sodwana Bay in the Isimangaliso Wetland Park. This find leads to the establishment of the African Coelacanth Ecosystem Program, or ASEP. 33 individual specimens are subsequently identified and catalogued according to the unique markings which appear on each fish, from footage obtained from the Jessa Canyon dives and numerous ROV and submersible excursions into the deep canyons of Sodwana. And now back to my story. After our Indian Ocean trip, I went back to university and completed my postgrad studies. I then got stuck into my career. We moved from Swaziland to Cape Town in the year 2000, and I struggled to adapt to the cold and often green water of the Cape. So for many years, my diving was limited to holidays in the tropics. Finally, in 2016, I traded in my wetsuit for a dry suit and started diving seriously again. I quickly got into technical and mixed gas diving. I bought a boat and set up a gas blending station in my garage at home. Gombessa was removed from a drawer somewhere, dusted off, and installed in a place of pride in my new home dive center. Diving with coelacanths was back on my agenda. I read all the coelacanth books, met with scientists that were involved in ASEP, and developed my plan to dive with Old Forelegs. A good friend of mine, Bux Potgieter, had participated in some of Peter Tim's Jessa Canyon dives, and he was a great source of guidance and inspiration. In 2019, my dive buddy, Mossie Carstens, and I did several deep water preparatory dives in Sodwana. We carefully planned an expedition for November 2019 to dive in the Jessa Canyon. A permit is required to dive in the Jessa Canyon, and this was proving to be a major challenge. Initially, the authorities said they would not issue the permit because there's no decompression chamber in the Sodwana Bay area. So I arranged for a one-person chamber to be transported to Sodwana for our expedition. I booked time off work and put all the necessary logistics in place, but alas, no permit was forthcoming. Our dates arrived, and despite knocking on every available door, we simply could not get the required permit. So eventually, I rang up my old mate and dive buddy, Mike Fraser, in Pumula, and told him that I'd had to abandon my Sodwana plans, but that I had some time off work and we were going to come up to KZN anyway and dive with him. Mike also had a long-standing interest in coelacanths, and as a boy, he had sat on the Pumula beach, wondering if coelacanths swam in those deep offshore waters. There's a massive canyon offshore from the Mzumbi River, and Mike's son Alan, fondly known as Moo, spoke of catching unusual deep water fish there in certain weather and sea conditions, and he was firmly of the view that we would find coelacanths. If the authorities will not give us a permit to dive with coelacanths at the Isimangaliso Park, then we would have to find our own. On the 22nd of November 2019, we launched from Pumula Beach for the Mzumbi Canyon. There were 4 divers on board, Mike and Moo Fraser, my dive buddy Mossie Carstens, and me. My son Ben and his friend Mark Jukes were the top men. We chatted about coelacanths on the way out, and I spoke fondly of my memories of the Comores. At 9:04, we rolled backwards off the boat and plunged down to 80 meters. 5 minutes into the dive, Moo started beckoning wildly and screaming coelacanth into his mouthpiece. There before us, under a rocky overhang was a massive 2-meter coelacanth. I literally did not believe my eyes. There is my video filmed with a GoPro in a special deep water housing. You can hear my initial disbelief and then wild excitement. It's no wonder that Mike, in a subsequent radio interview, referred to me as Howling Henderson. And did you notice the depth on my dive computer? 67 meters or 40 fathoms. When we surfaced, I called my mate Eve, who was based in Melbourne at the time, and told him I'd seen a coelacanth. He demanded evidence, and when I sent him a video snippet, he called back to say, just like the one I saw in the Comores. As mentioned earlier, RSSAf has a register of individual coelacanths filmed off the South African coast. We extracted several quality stills of both sides of our coelacanth, and with Dr. Kerry Sink of the South African National Biodiversity Institute, SANBI, we were able to confirm that this was a new individual, ASEP number 34. We called our coelacanth Moo, in honor of Moo Fraser, who had led us to the fish. There was a fantastic response in the media to our find, and in collaboration with Professor Mike Bruton, we wrote a paper on the find, which appeared in the South African Journal of Science in March 2020. When I returned home, I found that a couple of dive mates had been around to my place and placed a great big tick on Gombesa. We returned to the same site on a number of occasions, but we didn't find any more coelacanth until February 2022. On the 24th of February, 3 of us, Mike, Moo, and I, in ideal conditions, dived on the site again. We were all on rebreathers. When we got to the bottom of the reef at about 80 meters, I felt completely knocked, yet I was diving on a helium-rich trimix gas. I tried to turn my GoPro on, but the battery was flat. Things were not going well. The feeling of narcosis intensified. My heart started palpitating and my breathing rate accelerated dramatically. I realized that I was experiencing a CO2 overload. There must have been a problem with the scrubber in my rebreather, allowing exhaled CO2 back into my breathing loop. Just then, we spotted a coelacanth in a shallow cave. But I could feel my vision narrowing into a darkening tunnel, and I knew I had to bail out from my rebreather and go onto my back-out open-circuit cylinder carried for these circumstances. I shut off the rebreather loop and inserted the bailout regulator into my mouth. Instead of the lovely breath of sanity that I was expecting, I got a mouthful of seawater. The second stage on my bailout regulator had failed. Decision time. Move on to the 100% oxygen bailout intended for a maximum depth of 6 meters, deadly at 70 meters, or a CO2 contaminated rebreather loop, or seawater. I immediately went onto the rebreather loop and swam over to Moo. I grabbed the regulator from his bailout cylinder and indicated that we needed to ascend urgently. Together, we were able to ascend to 6 meters, where I could go onto my 100% oxygen and complete my decompression obligations. It was a horrible experience, but we made it out. The next day, on the 25th of February, with scrubber repacked, tested, GoPro battery charged, we headed back to the Mzumbi Canyon. And there, in the exact same cave as the day before, was our new coelacanth. We called it Bruce, ACEP number 35. Here's some footage of Bruce, firstly of us finding and approaching the fish, and a second video of some close-up. And then some close-ups. It was the birthday of my late mother and Mike's late father that day. They were smiling down on us. Mike and Moo Fraser returned to the site 10 days later and found and filmed our third coelacanth in a nearby cave. It has been confirmed as a new individual, RSSAf number 36, named Mike. We shared the exact locations of our finds with Kerry Sink of Sandby, and in December 2022, Kerry, on an RSSAf expedition, was able to fly an ROV, a remotely operated vehicle, in the Mzumbi Canyon. They detected and filmed 4 new specimens, bringing the total number of coelacanths filmed and identified in our Mzumbi location to 7. So where to from here? JLB Smith's theory was that the 1938 find was a stray, a creature from the tropics, and the Comorian coelacanths seem to prove this. The important Sodwana finds in the year 2000 shook this theory a little, and scientists started questioning whether coelacanths might be found further south. Our Pumula finds confirm that there are indeed more coelacanth populations along our coast, and that the 1938 fish may well have been a member of a local colony. You can see the several offshore canyons off our coast on this Google Earth image. The Sodwana canyons up in the north, the Mzumbi Canyon in the center, where we found Moo, Bruce, and Mike. And look at these massive canyons, canyons off the Chulumna River, south of East London, where the 1938 specimen was trawled. So it's a question of watch this space. Our vessel Reckless 2 is fitted with a state-of-the-art multi-beam sonar system, and we are currently busy with a seabed mapping program in the Western Cape. At a later stage, we intend to survey and map the Chulumna area with multi-beam sonar and dive on high potential reefs. Hopefully, we'll be able to find and film a coelacanth that once swam with a fish that started this whole intriguing story. Thank you very much. And I'm happy to take questions. I must just say at the outset that I've taken a leaf from Rassie Erasmus's book, and I've got a bench that's stronger than the starting lineup. And Professor Mike Bruton has kindly agreed to join us tonight, and he's going to help with answering any technical questions. Thank you.
Bruce, if you'd like to stop your screen share, please. If you'd like to ask questions, you can either put them in the chat, or you can raise your hands and I can see if I can see them. First of all, let me thank Bruce for a really, really interesting story. And it is very neat because in particular, the amount of work that he had to go to find the fish that he was chasing. And it reminds me of so many scientific stories that we hear in South Africa, where South African scientists just have to make a plan and continue trying no matter how adverse the circumstances. So I, for one, am very impressed with the efforts you made, Bruce, to find your fish. I'm really curious, if the fish that you swam next to seemed to be totally unperturbed by your presence. Is that how you felt at the time?
Yes, absolutely. It was totally unperturbed. And you can see in two of the videos how close we got to the fish. And it raised its dorsal fin. And, you know, that's apparently indicating alertness and a bit of caution. But other than that, it just remained in the same place, sculling away with those fins. Totally unperturbed.
What's also amazing is the way you can see in the videos how each fin is moving and independently of the other, and they seem to. It's almost as if you were something that you were making up rather than something real that you were watching. There are some questions in the chat. Let me read out the first one. How much do we know about the fish? Any idea of what it eats? And how old do you think the three fish, Bruce, Mike, and Moo, are? And do you know whether they're male or females?
I'll chip in quickly, and then Mike, if you don't mind, give us a bit more detail. We were of the view, with the help of people that know these things, that the first fish, Moo, would have been a mature female, due to her size. That's one of the bigger fish recorded, and I think we were able to get a decent approximation of her length at 2 meters, given that we had a diver so close to her. It's speculated that they can live up to 100 years. Mike, and the diet of fish, squid, etc.
Yeah, firstly, if I could comment on their docile behavior, when we watch coelacanths off the Comores in the Drago submersible to depths of 400 meters, Hans Fricker was able to go close enough to actually take scales off the fish and insert a sonic tag in it. They are amazingly docile animals. To confirm what Bruce said, the larger specimens over 1.6 meters are almost always females. And yes, they feed on fish, sometimes quite large fish, even up to 1 meter in length. And they hunt at night, and mainly using non-visual sensors, electroreception, vibration reception. And they are ambush predators who hover along just above the sea floor, and then detect the electrical field of their prey, perhaps under the sand or on the sand, and then pounce on it. And if I could add, from being a group of fishes that we thought were extinct, the African or the Indian Ocean coelacanth is one of the best known fishes in the world. Hans Fricker and his team studied this fish for a quarter of a century, mainly in the Comores, and did incredibly detailed studies of them. And in many ways, we know the coelacanth better than intertidal gobies and fish that are much more easily accessible.
Thank you, Mike. There's another question there for Bruce. Why did Captain Goosen make the contact? Did he notice a fish that was different?
My understanding was that Courtney Latimer had an outstanding relationship with several people in the area, enabling her to get various biological samples, including the INJ, the captains on the INJ fishing vessels. And he stated that he specifically cast that last net with the intention of collecting inedibles. But yes, it was so it was not only a matter of routine bycatch, but he did definitely notice this distinct, the weirdest looking fish he had ever seen.
Yeah, interesting the way in which Marjorie and Captain Gerson met. Marjorie had taken leave in late 1936 and spent some 5 weeks on Bird Island in Algoa Bay, collecting specimens for the East London Museum. And Gerson and his crew had planted rabbits on the island and would occasionally come and collect a few rabbits for fresh meat for the crews. And that's how they met. And Marjorie asked Gerson to take boxes of her specimens back to East London, which she agreed to do. And they then formed this wonderful relationship where the steam trawlers of Evan and Johnson, captained by Gerson, would collect specimens for the East London Museum. And as Bruce said, he specially shot his side trawl on the way back in December 1938 to collect specimens for the museum. And by an incredible coincidence, there was a coelacanth in the catch.
There's another question here about any idea, do you have any idea why the fish has white markings on it?
Mike, I'll start again, but what I think is interesting is when you look at one of those videos, the second video, when halfway through I turn our dive lights off, and it gives you the impression of how dark it is down there, and particularly in the rocky overhangs. And as soon as that light goes off, you just see how that fish disappears into the background and is perfectly camouflaged. So no doubt they are unique markings and have enabled scientists to identify individuals, but no doubt camouflage is one of the factors.
Yes, I agree with Bruce. In the Comores, if you switch the lights off, there are dead mollusk shells attached to the rocks, which have the same look and feel as these white flecks on the coelacanth's body. So it's all part of their camouflage. And just as an aside, at the moment we have a NASA scientist, Jim Adams, in Cape Town, and he was telling us that whale sharks are now being identified using algorithms developed at the Webb for the Webb Space Telescope to identify solar systems in the universe. And that same algorithm is now being used to identify individual whale sharks based on their pattern of white spots on a blue body. And we're looking at ways in which we can use that same technology to help identify coelacanths.
Okay.
The next question is a comment plus a question. South African artist Walter Altman has done some amazing paintings and embroideries of coelacanth. Would a collaboration be on the card sometime?
Yeah, we enjoy collaborating, and I know Mike's got a wonderful collection of coelacanth art.
Yeah, I've commissioned a number of artists and craftsmen and women to create 40-centimeter long coelacanth models, paintings, carvings, etc. So I'd love to collaborate with someone who can do an embroidered coelacanth. It would be wonderful. And just to say, I will eventually donate all of these craft and artworks to the East London Museum, probably in time for their centenary in 2024.
I don't see any more questions in the chats. So let me have one final question. Oh, sorry, there's a hand up. Bruce, would you like to go ahead, please? Unmute yourself. Bruce Rubich. Carry on.
Sorry, I'm a bit stupid with just handling technology. Mike, what is the current taxonomic situation of coelacanths? I understand from that there are two species, Latimeria chelumni and then the Philippine species. Are those the only two species? And how many specimens of the Philippine species are known? And what is their distribution?
Bruce, do you want to say anything first?
No, you go, you fire away, Mike.
Yeah, there are two species known of Latimeria chelumni, Indian Ocean coelacanth, and then Latimeria monadoensis from North Sulawesi Island in Indonesia. I'm not exactly sure how many specimens of monadoensis have actually been landed, because the tendency now is to rather photograph live coelacanths and not kill them. And also, we're not encouraging traditional fishermen to land the fish and offer them for sale. In fact, that's illegal. I think there are 5 monadoensis known, but I might be wrong. It's a smaller species, and instead of blue, it's kind of grey-brown, but it also has white flecks on it. And interestingly, the only newly born juvenile coelacanth that's been photographed in the natural environment so far is a monadoensis. And that's one of the key things we don't know about coelacanths, where the juveniles live, whether the parents carry out any guarding of the coelacanths. But a sensational finding, it was made fairly recently, is that the incubation period of the coelacanth, its pregnancy, is a phenomenal 60 months, 5 years, which is more than twice as long as that of any other animal. The next longest is 22 months for the African elephant. So it really is a fish of superlatives. I mean, we could run off probably 20 superlatives where the coelacanth is completely unique, and it doesn't fit into any of the boxes that we've created. And as Bruce said, it's most closely related to the lungfish, and the lungfish are more closely related to tetrapods than to the familiar bony fishes.
Thank you. That's very interesting. But now, Rob Guess's work suggests that these things, that in the Devonian, they were coming into estuarine areas to have their babies. In coelacanths, in the living coelacanths, that doesn't seem to be the case.
Yeah, well, Rob, I think, found an estuarine coelacanth. That doesn't necessarily mean it's a marine one coming into estuaries to breed. There are many freshwater coelacanths. In fact, we have a knowledge of more extinct coelacanths from fossils from inland waters than from the sea. And obviously, you know, that could be an artifact of the fact that it's much easier to find fossils of animals that were, you know, in inland waters than those in the sea. But coelacanths have inhabited freshwaters, estuaries, and the open ocean.
Thank you.
There's one or two questions popped up in the chat again. One was about the color varieties that I think you've already covered. And the second one is how many are in our museums that are preserved, and then what are its ancestors that's so unusual? Where did it descend from?
Bruce?
You go ahead, please, Mike.
Yeah, a very detailed inventory of coelacanths is kept of dead specimens and now also of live observations. This inventory was originally started by French scientists, and then we carried it on for a number of years in the Ichthyology Institute in Macondo, Grahamstown, and it's now run by Rick Neylands, a Belgian well, he's actually a retired engineer with an interest in the coelacanth, and he maintains the inventory of dead specimens. And I'm not totally up to date, but I think there are over 360 in that inventory. Most of them are in French museums in Madagascar, but especially in the National Museum in Paris in France. But they have been used as diplomatic gifts, both by France and South Africa, and also by the Comores, and specimens have been donated to museums all over the world. And that, of course, has resulted in a variety of different specialists studying those specimens and increasing our knowledge of them. And interestingly, J.L.B. Smith made many predictions about the coelacanth, where it lives, how it swims, how it catches food, what it eats, and all of them were correct except one, and that is with regard to the breeding. He suggested that they have sort of egg purses, like mermaids' purses, similar to sharks, but it was subsequently discovered that they are placental live bearers. And this discovery was made on a female specimen that was originally offered to J.L.B. Smith, but he refused it because he felt his coelacanth work was over, and he asked for it to be sent to the Natural History Museum in New York. They received it with thanks, put it in the collection, and it's sat in the collection for, I think, about 14 years before they decided to dissect it. And when they dissected it, inside were some new, about to be born coelacanth pups. And, you know, we now know that the coelacanth has one of the most advanced breeding methods of any vertebrate, let alone any fish.
The second part of that question was, do you know what its ancestors are and where it descended from?
Yeah, the work of Richard Cloutier, who's one of the paleontologists who's worked on the coelacanth, indicates using cladistics, and I think it's most closely related to a genus called Macropoma, which consists only of extinct species. So, you know, the paleontologists have worked out who their closest relatives are, but of course, none of them survived the Cretaceous extinction, as far as we know. And I think it's also important to realize that there are no fossil Latimeria specimens known, even though they've obviously been around ever since that Cretaceous extinction.
There's two more questions that we can go through. One is going back to pregnancy. Why do you think it would take so long? And the person asking the question is suggested perhaps because of the temperature down there, and what sort of temperature is at these depths that these fish inhabit.
Well, Bruce, do you want to comment on the temperature question?
I'll comment on the temperature. We've so it's interesting that the 1938 find was in circumstances of a cold water upwelling, when these fish might be coming into shallower waters, and that's been our experience as well in the three fish that we've seen. It's definitely when we experience cold water upwellings, and I think that on each occasion the water has been not very cold, but sort of 16, 17 degrees, where we've had surface temperature of about 25. We'd get some sort of thermocline and colder water, and that's when these fish might be moving out of the deeper canyons onto the canyon heads. That's been, and then as Mike indicated earlier, in the Comores, where they've been filmed with submersibles, etc., they've been found at much greater depths. And again, that would probably be a function of cold water, where we're getting much warmer water down to 100 meters in the Comores, still north of 20 degrees.
Yeah, the 18 degree centigrade isotherm is obviously much deeper in the Comores, but their preferred temperature range does appear to be between 16 and 18, or maybe up to 20. The only specimen caught found off Mozambique was a pregnant female, which was about to give birth to a big litter of coelacanth pups, and that was up on the continental shelf. And we think this may be some behavior related to the release or the birth of the juveniles, because it was a very abnormal place to find them.
And the possible relationship between how long the pregnancy is and the temperature, I think there's some relationship there, Mike?
No, I think that's part of the breeding strategy. Fishes basically have three main breeding strategies. So one is non-bearers, who the fertilized eggs are simply released into the open water, typically drift in the plankton and are afforded no parental care. Then the next group are the guarders, who create a nest or in some way guard the young. And then the third and smallest group, about 15% of all fishes, are internal bearers. And they can carry their eggs and young in their mouth, or more typically in the oviduct. And the coelacanth is one of the most advanced of those internal bearers, in that the juveniles grow to a large size, about 33 centimeters and 500 grams, which is the size at which they're born. And the reason for the long pregnancy is basically for the juveniles to grow to a stage where they can defend themselves when they are born. And because that strategy is a sort of low risk, higher parental investment strategy compared to the non-guarders, which is a high risk, low parental investment strategy. So, having a long gestation period and producing large, well-formed young is a strategy that some fishes, including many sharks and rays, have adopted.
And then final question is there any possibility of another amazing discovery like this? And are the searches at the moment based on research? Was this just a once-off, do you think?
Bruce?
I think that we were very, very lucky. I mean, it was the most remarkable event when we found this fish. It was surreal in that we had so carefully planned our trip to dive in Sodwana, and then coming across this fish on the south coast was extraordinary. But we are diving to greater depths more frequently, and the submersible technology has improved tremendously. So I think that there will be more finds. I'm pretty confident that there are coelacanth populations along our coast. There's several habitats that are suitable, and also the mapping technology is so advanced. So as we get a better understanding of what the seabed looks like, we can be more specific in where we look. So I do think that there will be more finds, and I think it would be quite significant if we were able to record coelacanths in that Chilumna area.
Yeah, I agree with Bruce. There's still a whole lot out there to find. If I may give an example of a different fish, in 1976, a huge shark was caught by accident in the sea anchor of an American naval vessel off Hawaii. And it's now known as a megamouth shark, and was described by a shark expert, Len Compagno, who was then in California and subsequently worked at the Ichthyology Institute in Grahamstown and also at the SA Museum. This is a 14-meter long shark with a very deep belly and huge gape, and it's been swimming around in the oceans until 1976 without being discovered. And since then, just a handful of specimens have been discovered. And of course, the giant squid, there's still people who feel that there are very large squid out there that haven't been caught. But one exercise which is rather amusing, a sperm whale was found with squid sucker marks on its skin about 1 meter wide, and that extrapolates up to an enormous squid, until scientists found that if a young sperm whale is attacked by a squid and sucker marks form on its skin, as the sperm whale grows, the sucker marks get bigger. So one has got to be careful of that. But in terms of coelacanth, I agree with Bruce that we're likely to find them elsewhere off the South African coast, perhaps the Transkei coast. And in Mozambique, we know that there's a series of canyons up in northern Mozambique. And if ISIS would just allow us in there, or we can find the funds to do it from offshore, I'm pretty sure that the canyons in that area will yield coelacanths. And ironically, the last scientists to do detailed marine work up there were JLB and Margaret Smith in the late 40s and 50s. It's an area absolutely crying out for further research. And then if I could comment, Hans Fricker is convinced that coelacanths, maybe another living species, occur around the Pacific Rim of Fire, where there's so many active volcanoes forming overhangs and so on, as in Grand Comore. So you know, there is a search going on for those possible specimens as well.
Thank you very much, Mike. It remains for me on behalf of the
Sorry, do
participants.
you mind if I make a final a comment myself?
Please go ahead.
Yeah, if I could just say that, you know, I want to salute the incredibly brave and courageous research that Bruce and his team have been doing. We need to remember that our coastline is hardly explored at all, and there are insufficient South African marine scientists and ichthyologists who are suitably qualified as either scuba divers or especially as mixed gas divers. And the role of citizen scientists like Bruce and his team is absolutely vital in furthering our knowledge of the marine environment. And I'm so glad that the Royal Society agreed to host this talk, remembering that our motto is something along the lines that progress through experience. There's no specification that you have to be a qualified scientist. If you are a competent diver and someone with a good scientific sense, you can make just as many discoveries as a qualified scientist. And let's remember that J.L.B. Smith himself was not an ichthyologist. He was a chemist when he made his first discoveries on the coelacanth. Thank you.
Thank you very much. Thank you very much, Bruce. I found your talk absolutely fascinating. I would recommend that people go, if they want to have a taste of a few more videos or look at these videos again, they're on the recklessmarine.com website. And some of those images are just absolutely fascinating. Thank you very much for sharing both your knowledge and your experience with us this afternoon in such a fascinating way. Your talk was really amazing. Thank you, Mike, also for joining in and answering questions. I'd like to thank the participants for being here and for joining in the discussion, which has made it brought up some interesting points that were brought up in the discussion, and that's really nice that people are participating and that we can learn so much more from your answers and from the questions that people asked. Thank you very much, everybody, for your participation. Thank you again, Bruce, and we look forward to hearing what your next adventures are.
Thank you very much, Dean, and a big thanks to Mike for assisting us with the questions. I really appreciate that. Thank you, everybody.
Thank you, everybody. Those of you that travel, safe home. Otherwise, look forward to seeing you next time. And I remind you that there is a talk on the 15th of November. On behalf of the Royal Society, thank you very much and goodbye.
Thank you. Thank you.